Understanding thunderstorms, the formation and electric discharges. Thunderstorms are one of nature's most dramatic displays, characterized by powerful winds, heavy rain, and, of course, the striking flashes of lightning that light up the sky. But what exactly causes these storms to form, and how do they generate the electric discharges we associate with them? Understanding the process behind thunderstorms reveals the intricate interplay of atmospheric conditions that lead to these electrifying events. The formation of a thunderstorm begins with specific meteorological conditions that create an unstable atmosphere. As this warm air ascends, it expands and cools, leading to condensation of water vapor into tiny droplets. This process forms cumulonimbus clouds, which are the towering clouds associated with thunderstorms. These clouds can reach impressive heights, sometimes exceeding 20 kilometers, about 12 miles, and are characterized by their anvil-shaped tops. Once a cumulonimbus cloud develops, it enters a three-stage life cycle: the developing stage, the mature stage, and the dissipating stage. During the developing stage, warm air continues to rise and cool, allowing more moisture to condense and form larger droplets. As these droplets coalesce, they create a cloud that can produce significant rainfall. In the mature stage, the storm reaches its peak intensity. Updrafts of warm air continue to feed the cloud while downdrafts of cooler air begin to form as precipitation starts to fall. It is during this phase that thunderstorms exhibit their most severe characteristics: heavy rain, strong winds, hail, and intense electrical activity. The collision of particles within the cloud, such as water droplets and ice crystals, causes a separation of electrical charges. The top of the cloud typically becomes positively charged while the base becomes negatively charged. This charge separation creates a significant electric field between the cloud and the ground, or between different parts of the cloud itself. When this electric field becomes strong enough to overcome the resistance of air, it results in a discharge known as lightning. Lightning can occur between clouds or between a cloud and the ground, producing bright flashes that are often followed by thunder, the sound produced by the rapid expansion of heated air around a lightning bolt. The conditions necessary for thunderstorms include not only warm, moist air, but also lifting mechanisms that help initiate convection. These mechanisms can include weather fronts, where warm air is forced over cooler air, topographical features like mountains, or localized heating from the sun on a hot day. Each of these factors contributes to creating an unstable atmosphere conducive to thunderstorm development. As storms progress into their dissipating stage, downdrafts dominate as cooler air sinks and cuts off the supply of warm, moist air necessary for sustaining the storm. Eventually, this leads to a decrease in precipitation and electrical activity until the storm dissipates completely. In summary, thunderstorms are complex phenomena resulting from specific atmospheric conditions that allow for rapid vertical development of clouds and significant electrical activity. Understanding how these storms form not only enhances our appreciation for their beauty but also underscores their potential dangers. As we continue to explore weather patterns and their impacts on our environment, many questions arise about how climate change might influence storm frequency and intensity.